Well, ladies and gentlemen, why don't we get started? Welcome. My name is Jeff DeBelko. I have the good fortune of being a professor in the Voynich School and director of the Environmental Studies program. On behalf of the Voynich School, the Department of Geography, and our hosts here at Scripps College, it gives me great pleasure to welcome Dennis Dimick to campus, back to Athens after a 37-year gap, and maybe he'll tell us what brought him here 37 years ago. It's a good story. Has a lot of local characters, maybe. Dennis, as I think you know, is executive editor environment for National Geographic. He started out, grew up in Oregon, working on a farm, and came to be interested and knowledgeable about issues of our natural environment that way. He studied agriculture at Oregon State, studied agriculture journalism at University of Wisconsin, a degree that I don't think you can still get there, maybe a couple other places. And then worked, as so many folks in journalism do, at a small paper and then a larger paper down here closer to us, the Louisville Courier-Journal. And in part, with some connections to OU, found his way to National Geographic 35 years ago. Dennis is very active in environmental journalism. I've seen him speak multiple times at the Society of Environmental Journalists, an organization for any of you, particularly students interested in this. It's the go-to place to get connected and learn how to practice the profession of environmental journalism. Dennis has been a leader in conceiving and editing and working with photographers, and he's a photojournalist himself, and writers, to tell some of the stories that we have so enjoyed and learned from in National Geographic. So, series on climate change, series on food, series on water, on 7 billion human population, and just this month he very conveniently managed to schedule, probably 2 or 3 years ago, but for November of 2015, a special issue on climate change that I urge you to check out. So Dennis is behind those series and so many more stories. And we asked him to campus here as part of Geography Week, and particularly today, GIS Day, and a set of activities, this being the keynote, but just downstairs, colleagues from across campus have all sorts of, from drones to, well, it's fantastic. Afterwards, catch Dennis and catch all our colleagues downstairs. To check out all the interesting things that are going on campus here with GIS, and follow up with folks in geography and Voynich School in particular who are doing that. So Dennis, I would turn the floor over to you. We'll turn the lights down a little bit so that the photos really pop off the screen. So Dennis, welcome to.
Thank you, Jeff. It's a great pleasure to be here. So I'm going to get the origin myth out of the way immediately, okay? So in 1979, I came here to speak to a Viscom class where Terry Eiler was the instructor. And one of the students in that class was Rick Perry, who worked at the New York Times. And I had met Rick because he was a kind of a perpetual summer intern. And he when I worked in Walla Walla at the Union Bulletin, he was our summer intern in 77, and then in 78 I went to the Courier-Journal, and here was Rick Perry, our summer intern again. So he called me up one day and he said, so Terry's going to give me an A in my class if I can get you to come up here and talk to us about what it's like to work at a small paper in the Northwest and a big metropolitan paper. And at the small paper, we did all the page design. We did the whole thing, soup to nuts, write, layout, design, the whole thing. And as a picture editor of the Courier-Journal, I did the same kind of thing. I was laying out section fronts. I was designing the front page in collaboration with managing editors. So there was a lot of correlation, but there was a difference. And so about 6 months later, I got a phone call. I was getting ready to do the 4 p.m. news budget meeting, and a phone call came in. And the call came from John Agnon, who is a Athens native. And he was a picture editor in the book group at National Geographic. John is here with us today. And he said, we have an opening here for a picture editor at National Geographic, and we want you to send in your resume. And I was going, oh, okay. So, and I said, where did you get my name? And he said, I got your name from Terry Eiler. So that was the connection. And Terry had also been he'd been an intern at the National Geographic. So things go around, they come around, and that's how it all happens. And that's why I'm standing here today, 35 years later, thanks to John and to Terry and the chance to have been here 37 years ago. Enough of that. So what I'm going to do is I'm going to try to mix together all this stuff that you heard from Jeff. I'm going to try to sort of weave out a big narrative about our place on the planet and then talk about a bit about, well, what can we do going forward? That's really what it's about. And so I want to start first with me. I'm going to put you where I grew up, right here, okay? Right there. This is the Pacific Northwest. This is a new picture from NASA that came out just a few months ago. So this is all my home territory here. I spent my life as a child up in these mountains. What's going on? Anyway, so then I happened to see this, actually. I wasn't even planning to be here, but I was trying to get to LA, and so they flew me from Medford to Portland on my way last summer, and this is a part of the world that is very dear to me. I've spent a lot of time driving up and down the Columbia River Gorge to my jobs in Pendleton and Walla Walla back to Portland. And so this for me was almost like it was worth the price of admission to see this. But this is where I grew up. This is one of my early pictures in the early 70s. I grew up on a small farm about 2 miles from this scene. This is in the local school district. That was Mount Hood. This is the house that I spent most of my years in as a child. About 1960, we built a newer one. But this was the life I led as a child. Small. It was like, it's hard to imagine pinch me. But then this is what I did to earn money to go to college. I baled hay, drove tractors. I'm sure I'm going to get skin cancer at some point, right? We'll find out. But this is what I did. And $10 a ton, cut, rake, and bale. We charged 12 by the time I left this occupation. This field is all covered by large mansions now. And so then this was one of the early published pictures. We used to raise registered purebred Suffolk sheep. This is my younger brother. She just had a lamb. You can see the afterbirth. So this is right after the lamb was born. And then this is as my photographic career advanced, I became more sophisticated. And this is I'm in my later Grant Wood American Gothic phase. This is my parents, John and Mary. They were both fisheries biologists, and he had this hobby farm. And so this was where this whole lab of learning about the planet, learning what all the connections of life, they were made real for me. And so then 6 years in newspapers, fast forward to after the origin myth you heard that I told you earlier. And so then I got involved I was editing books at National Geographic, and in '91 I moved to the magazine and got involved in driving coverage of environmental issues. And so what you see here really is I'm just going to run through these. Climate change, disappearing ice, energy, a special issue, a cover story on soil conservation, biofuels, energy conservation, fracking, extreme weather, rising seas 2 years ago, a special issue on water, a series on population, food last year, and climate this month. All these I've had a hand in various ways, and so it's essentially what it is. It's been a conversation with our readers over well more than a decade, trying to help build connections with our readers. And so I'm going to try to draw those connections for you today. And we'll call it our planet story. We can also call it the human story. Or we can also call it the Anthropocene. I don't know if you've heard this term, but it was coined about 15 years ago by Eugene Stormer at Michigan and Paul Crutzen. And it was this idea that we're entering this new age. And what it is it's like a proposed geologic epoch, they call it, after the Holocene, which we're in, that's defined by our massive impact on the planet, where the mark of our presence will endure in the geologic record long after we're gone. And there are questions about, well, when did this begin? Did it begin 8,000 or 10,000 years ago when we started farming? William Rudiman at University of Virginia has talked about this, done research on it. Did it begin at the beginning of the Industrial Revolution when we started digging coal up and burning it, and we changed the carbon record, and we see this in the ice cores? Or did it start at the nuclear age when we started blowing up bombs, and the sort of the residues of those nuclear explosions are seen in the rocks. And just this past year, actually, there's been a whole new thinking about when did the Anthropocene start. It may have started in the 1500s after the European settlers came to North America and brought the diseases with them and caused a massive die-off in native populations, because what happened, there was after that happened, huge amounts of North America reforested in the succeeding decades because all the people who had been farming that land had died off, and you actually can see that drop in global CO2 levels in the ice core records as a result of that massive die-off of natives in this continent. So this idea of the Anthropocene, it's on the cover of The Economist 4 years ago. I was at a conference where we talked about this, and we did a story as part of our series on population, and it was called The Age of Man, Enter the Anthropocene. And it was this idea that, it's like we own the planet. It's sort of like we broke it. Now it's our job to sort of fix it. And so what does that mean? And so let's take a step back. The paradox for me of the modern world is this. When we think about that, what does that really mean? Well, let's talk about what that means. This fire from the earth that we dig up, we drill up, we light it. Okay? Let's go back in time. This is a wonky graph from the USGS, but I'll try to make sense of it. So that's Earth way back when, right? 4.5 billion years ago. 300 to 400 million years ago, the Pennsylvanian and Mississippian period. Keep that in mind, because that is the period of time when all of these fuels that we dig up today were created. Big tropical forests, they eventually were buried, and that's what the carbon-rich fuel. Okay, long before the dinosaurs, okay? That period right there, the 300 to 400 million year old period, long ago. And here's where we are. We're just here in the last 11,500 years of all of this. And so just at the very end of this last very long time frame, we have transformed the planet profoundly. And so what we do is we power the modern world by burning the fossils of 400 million year old plants and animals. We basically are digging up the fossilized carcasses of ancient plants and animals and lighting them on fire. That's how we power the majority of our modern world. 2/3 of the electricity in this country comes from coal and natural gas. Those are ancient fossils. Really? You'd think we'd have a more sort of modern approach. So let's talk about the basic idea, Earth and sun. Current sunshine, right? Sun rises every morning, puts energy on the earth. Photosynthesis captures that energy, grows plants, grows algae in the oceans, food crops. It's the essence of life. It grows everything that we rely upon, cultivation, all of everything, the soil. It's all dependent upon the fact that the sun is shining today. Until we discovered fossil fuels, we'd grow forests, we'd cut forests, and we would burn the wood. That was essentially a contemporary or a current sunshine economy until about 300 years ago. But then what we did, we discovered fossil sunshine, just like that current sunshine, just like the wood, but this is fossil sunshine. All we're doing is digging up sunshine from 400 million years ago. That's all it is, ancient sunlight. We're digging it up. We're digging big holes in the ground. Here, for example, this is the Hobart 21 mine in West Virginia. One of the largest, this is a huge, you can see this from space for sure. And we put this in an article last year. And just to give you, this is what we're doing so that we can produce a little more cheap electricity for a few more hours. And if you're flying from Houston to Washington, that's what you see along the Kentucky, West Virginia border. That's what we're looking at. That's what those things are if you haven't seen them before. They also do it in Wyoming. This is where most of the electricity in the eastern United States comes from. This is low sulfur coal in the Powder River Basin of Wyoming. This is where most of the coal in the United States gets mined. And it is, as John McPhee has said, we have created the world's largest conveyor belt to ensure that the lights stay on in the eastern United States. Back when there were more than 600 power plants burning coal in the U.S., McPhee wrote a piece for the New Yorker. He talked about how we had the world's largest conveyor belt, 600 trains moving back and forth simultaneously all across the United States just to move coal from Wyoming to the East Coast. So what you see here actually is, this is a coal yard in Chesapeake, Virginia, and each one of those cars carries about 100 tons of coal. That's enough coal to keep this one power plant going in Georgia for 1 week. And so it's a very powerful energy source. It drives the global economy. This is China. China has benefited tremendously from the presence of coal, but as you can see from the atmosphere, there have also been environmental impacts. It's not just coal. You've probably heard of hydraulic fracturing. I took a lot of these aerials because I'm just curious. I look out the windows of airplanes, and then I actually go back and I use Google Earth if I don't have GPS on the camera. If you have an iPhone and you take a picture out the window of an airplane, it will record the GPS info even if you have it on airplane mode. Think about that. So if you ever see anything, I do it all the time. So this is near Odessa, Texas. What you're looking at here is hydraulic fracturing for oil. This is in Wyoming. This is in Alberta. Have you heard of tar sands or oil sands oil? So what we have here is, this is boreal forest, the large subarctic forest that goes across Canada and Siberia. In Alberta especially, there's oil that's underneath. And so what they do is they take these forests and they scrape them away so that we can get to the oil underneath. And until recently, about 10% of the oil that the U.S. burns comes from Canada, about half of it from these kinds of operations. But it comes at a higher environmental cost. This is the Deepwater Horizon disaster in the Gulf of Mexico in 2010. So our reliance on coal, oil, and gas, though it has provided a great benefit to us, has built the modern world. We're here today, the lights are on. I came here using fossil fuels. You know, it's nobody's fault. Everybody's, it's like this is the world that we live in. Every year by burning fossil fuels, we release 1 million years of photosynthesis. This is Dan Nocera, who's now at Harvard. He was at MIT. He's a chemist who spent his whole career trying to figure out how can we power the world without adding more carbon dioxide to the atmosphere. He's trying to make solar power a 24/7 operation. To put it in another way, every year by burning fossil fuels, we release 1 million years of stored carbon. No wonder we have a problem with CO2 in the atmosphere, because we're taking 1 million years worth of stored plants, we're digging them up and we're lighting them on fire. No wonder we're seeing CO2 go up in the atmosphere. But there are benefits. Look, there's benefits. Look, the party goes on, right? Right? Let there be light, right? The world is electric. And if you look, you're looking at the benefits that have come from those ancient fuels, except perhaps if you look here in places like Africa, what you see there, though, is that area actually really becomes one of the big challenges for all of us in the world. How are we going to be able to provide for the people who live there the same benefits that we enjoy here without also keep jacking up the carbon emissions? Can we do that? Can we do it with renewables? We're spinning the wheels of modern society. We're flying in airplanes. All of these things all depend upon this. And another thing, fossil fuels have been so profoundly significant in the rise in the availability of food in the last 60 years or so. It's mechanized agriculture. The invention of synthetic nitrogen fertilizer is tied directly to the availability of natural gas, which is a fossil fuel. Half of all people on the planet today are alive because of this one invention that was made about 100 years ago in Germany, synthetic nitrogen fertilizer. We grab nitrogen for the atmosphere and we use it as plant food. And so it's caused a tremendous uptick in global agricultural production, whether it's wheat in Kansas or corn in Iowa or soybeans that are being put on ships to go to Brazil or China so that we can eat more meat, because more people want to eat higher quality protein, eat higher on the food chain, more eggs. And we see it dramatically here, this picture that George Steinmetz did last year for our series that we did on food. He said he was in China 20 years ago, and the composition of those plates was exactly reversed. These are primarily meat, shellfish, animal protein, and 20 years ago it was primarily plant protein. So that in one sense, it's okay to eat higher on the food chain, but it also has impacts on the earth in terms of the demands on production, but also it has impacts on our health. So all this, energy, food, guess what? More people, right? So you have 1.6 billion in 1900, and 1 century later it flips, 6.1. In 2013 we were at 7.1. That's why we did the series in 2011, because we hit 7 billion. And by mid-century we're looking at this. And the last year the UN said that maybe by the end of this century we're actually going to be up towards 11. So that's a lot of mouths to feed, you know. So here we are right now. And so I was born in 51. I've seen almost world population triple in my lifetime. That's a lot. I mean, and so there's a footprint issue. So we have more people, we have more bowls that we need to fill every day, and we also have more demand for things like fresh water. So what in essence it all adds up to, this is not really about climate change, it's more about dominion and a transformation of the planet. And so what we've done is we've built our gleaming cities abroad. And here, and cities actually are beneficial in some regards because it reduces your individual impact because you're living close together. Like here, this suburb of Chicago. We've built our highways, and we've moved to the far off quarters. I mean, one of the biggest issues we face is sort of the expanding suburbia, and we're taking our best farmland and turning it into instant lawns and housing developments, right? But then also what we've done is the world's forests, which are some of the most important, and they call them carbon sinks, things that we use to soak up carbon and keep the climate happy. We're burning them up and we're cutting them down so that we can grow more food. That's one of the primary ways we've been able to expand food production in the last 15 years. We grow it on more acres. We're actually not getting more per acre. We're trying, but it's hard. Or we're taking biologically diverse rainforests like here in Borneo, and we're cutting them down and turning them into palm oil plantations. We're also taking the rivers, the free-flowing rivers of the planet, we're damming them up. This is Shasta Dam in California. Why? For electricity, keep the lights on. For irrigation, so we can grow more crops in dry areas. This is the Central Valley of California a couple of years ago. It's like, this is the salad bowl of America. This is where people, if they want to buy lettuce all year long, generally it comes from a place like this. But if you look around, what you see is things like the Yellow River in China. It's running out of water. The water isn't even getting to the sea. This is the Colorado River, and if you look way up in the top left, right corner there, you see a little bit of blue. The Colorado River hasn't made it to the Gulf of California for about 2 decades. And so last year, the Department of Bureau of Reclamation said, let's see if we can get some water down to the Gulf. So there comes the water. That's it. That's all that came down. But another thing that's happening is surface water goes away. We're also, if you've heard of aquifers, it's a big issue in the West where you get subterranean water. People get their water from wells, and out west it's very important with big aquifers. In northern India, they're running out of surface water, so they're mining aquifers. This is fossil water. It looks great, but they're actually drawing down finite supplies. In the Central Valley of California, because they ran out of water, surface water, they're drilling wells so that they can keep their almond trees going. This is a scene I saw in March this year. It's like, this thing is like 1,800 feet deep. But what you see here, this is from GRACE satellites. This is a project from NASA. It's 2 satellites flying over the planet, and they can determine the depth of groundwater supplies. And what you see here is over 12 years, the red means we're losing water. So the Central Valley of California is losing its water supply. Here's a vivid example of the Aral Sea over the last 14 years of what's happened to it as our demand for water has exceeded the available supply. And what's happened here is that this used to be like the world's 4th largest freshwater lake, and it got depleted because they were diverting water upstream from the rivers that flowed into it so that they could grow cotton. So the signs are visible of change. One of the most interesting things about this is what may be called the Great Acceleration. And about, in the early 70s, this formula has been modified a little bit, but what it is, it's an interesting way to think about impact. And so what John Holdren, who's the White House science advisor and Barry Commoner, came up with this idea. It's like, okay, impact equals population times affluence times technology. That being said, technology it's not bad. It's like, it's a measure, okay? All these things are measures. So what we're trying to do is to try to get at a way to, how do we quantify impact? And so what you see here, if you see the boxes at the bottom, the little box is 1900. That box, the bigger box, is 1950. So they multiply, they give you the X, Y, Z. So that's the cumulative impact of all of us in 1950. In 2011, that's it. So there's been this kind of big acceleration when you think about cheap energy, global energy, high productivity of food. All of a sudden it created the conditions. The Canadian scientist Vaclav Smil has called the invention of synthetic nitrogen fertilizer the igniter of the population bomb. So what you have then is you have this whole uptick, and I showed you the population curve. This, for example, this picture, everything in this picture that you see came from oil. So we're deeply embedded in this kind of this economy that we're highly dependent upon it. The Global Footprint Network has said that, so what we're doing currently, planetarily wise, is that we're living as if we had a Earth and a half, and if everybody lived like us, we'd need 4. It's just a way to think about our place. And so then you talk about what are some of the visible measures, or what are the real measures? One of them is actually CO2 levels. And if you haven't heard actually this zigzag thing, it's actually pretty interesting, because that within each year, CO2 levels go up and down. What that is actually it's northern hemisphere trees coming into flower and leafing out in the early spring and summer. And so they're soaking up lots of CO2. And then in the fall, when the leaves go off, the CO2 for that year goes up. But what you see inexorably is you see an increase. And most of that is coming from the emissions from burning that ancient sunshine that I was talking about. In the climate issue this month, we did a story on sort of Earth sensing. I was the editor of this. To me, it's really fascinating, this, like, what are we finding out about the planet? And the picture on the left is showing all of the Earth sensing satellites, atmosphere, land, water, all of those things. But one of these, this one on the right, this is actually one of the very first pictures ever published from a new satellite called the Orbiting Carbon Observatory. And it went up last year, and its goal is to measure and to show us carbon dioxide in the atmosphere. And so this is, for the very first time, we're actually beginning to see a picture of where this stuff is coming from and where it's going. And this picture that was taken in mid-June of this year, what's notable about it is, look across Siberia. It's all green. That's that same interannual zigzag I was showing you. Those are all the trees across Siberia and Russia coming into bloom, soaking up CO2. So trees actually play a really big role in sort of helping control the climate and helping the chemistry of the atmosphere, which we're changing. And we need to understand that, like, look, without CO2, the planet would freeze. There's a thing called the greenhouse effect, and it's very real and it's very important. You have carbon dioxide, nitrous oxide, you have methane that comes from natural gas, all those things that are up in the atmosphere, and they're sort of like blankets on our bed. But the reason we focus on CO2 is because it lasts so long in the atmosphere. Once it goes up, you know, it's like half of it's there after a century, a third of it's there after a millennium. It makes a difference. And so what happens is you put it up there, and imagine this, it's like adding more blankets to your bed. CO2 acts like an insulator, and what happens, the visible light comes in, it bounces off the Earth, then it becomes infrared. You can't see it, it's radiant heat, we call it. It's like if you held your hand up in front of a fire or an iron, that felt heat, that's the radiant heat. And CO2 traps that stuff. That's why we're beginning to see changes in the planet. But this has happened forever, if you want to know the truth. If you look here, the change in the climate of the planet has always changed, and it has done so because of a variety of things. The change in the orbit of the Earth, circular to elliptical, and this has happened over 100,000-year timescales. Also, the way the Earth behaves. Its 23.5 degree axis hasn't always been that. And then the Earth wobbles on its axis. Maybe not in our lifetimes, but over geologic history, scientists have been able to figure this out. And they have found this out through things like ice core records. And like here, this is Lonnie Thompson from Ohio State University, one of the leading glaciologists in the world. These are actually records of the history of the planet here. And he has climbed up onto glaciers in Greenland, in the Andes. Big records have come out of Antarctica. 800,000-year records of what the climate was like. It traps CO2 inside it. And it also comes from tree rings or stalagmites in caves. That one thing on the right, 130,000-year record of the climate of the planet from a cave in Missouri. You can also see it from seashells. It's like, they're called proxy records. To me, paleoclimate is really one of the most fascinating areas. You're trying to figure out what was the climate of the planet like before we were around, before we had thermometers, anemometers, all that stuff. And what they've done is they've actually created this record of over, it's even longer now, but 400,000 years of CO2, temperature, and sea level. They're all you could call them time travelers, and they all go together. And what you see here, the blue line, right, the blue line is CO2 level, the yellow is temperature, and sea level is green. And what you see is that we've overlaid the orbital variations. And there's a correlation between CO2 temperature and sea level through history, coming back from the ice cores. But the rub is right now that CO2 is way up here. So if you look at the past as a guide to the future, what we're seeing is CO2 is up. That means temperature and sea level, they're going to be coming. They have to, if you're willing to accept the scientific record of what we've seen in the past. But we're already seeing changes. Here, for example, this is an animation that NASA Goddard did, and they used the period of 1951 to 1980 as the average temperature of the planet. You got to pick one. So this is from 1880, which was the beginning of the scientific record, okay? And so what we're seeing now is once you get up to about 1950, here we go. This is average. But then what you need to watch for, once you get past about 1980, something happens. And so the things warm up. This is what we've been seeing globally, and there's been visible impacts of that. So you get to 2014 and you look and you go, oh, well, gee, it's more than 2 degrees centigrade. What is that? 4, 5, 1.8, 3.6 degrees Fahrenheit. That's about what it is. In some areas, the Earth is warmed 15 degrees Fahrenheit. So what does that look like? Well, here, let's look at Greenland, for example. We've been losing ice in Greenland. We've been seeing rising sea levels. This is an island in the Chesapeake Bay that's disappearing. This is the Columbia Glacier in Alaska. This is 2006. This is by Jim Balog, who did the Project Extreme Ice Survey and was in the film Chasing Ice. This is 2006. This is 2012. This is Arctic ice, 1979 to 2012. The first picture of Arctic ice was taken in 1979. They take it in the summertime when the summer melting is done. And this was the first satellite picture. By 2012, half of the Arctic ice had disappeared. We actually, at National Geographic, redrew the atlas of the world to reflect this change. Also, changes we're seeing but have not been discussed much is the acidification of the ocean. And as the ocean tries to soak up all that CO2 that we're putting in the atmosphere, not only are atmospheric levels going up, levels of it in the ocean are going up too, because the ocean is trying to soak it up. And it's changing in what's called the pH, or the acidity of the ocean, and it's going down ever so slightly. And so here what we did was as part of a project, we tried to simulate what acidity of the ocean would be at the end of the century, and we used a pteropod here, which is sort of the starfish of the sea, or it's a little shell in the sea. And so this was day 0, and 45 days later the shell had melted. The problem is that as the seas become more acidic, it makes it harder for shelled organisms shells, corals, even the skeletons of fish to form. So when you see an environment like this off of the coast of Italy, off an island of the coast of Italy, a healthy ecosystem, what you do is you turn around and this is what you see. This is actually an island. This is what it looks like on the bottom of the sea next to a vent off the coast of Italy that's venting CO2. So you get an idea what is in store if we keep lowering the pH of the oceans. We've also seen changes in the seasons, growing seasons. Winters aren't as cold as they used to be. Maybe not last year here in the eastern US. My pipes froze, right? But in the west it was completely warm. But so let's look here, 1990, let's put a dot right here in Athens, okay, and then we're gonna go ahead 16 years. Watch the blue, the purple and the blue. See, growing seasons are moving north. Growing seasons are getting longer. The last freeze date is getting earlier. The first freeze date in the fall in general is getting later. Growing seasons are getting longer. The weather is changing too, and there's 4 qualities when you think about it: air temperature, moisture, extreme rainfall, and heat waves. And this is from a project we did in 2012. What we're seeing is air temperatures on average up 1 degree centigrade. When you have warmer air, you also can hold more moisture. This is from physics class. Warmer atmosphere is able to hold more moisture. So we've seen an ability of the atmosphere to keep more moisture in it. And as a result, we're seeing more extreme rainfall events in the US, up 7% in 30 years. But one thing we're really seeing, and this is one of the strongest indicators, we're seeing more heat waves by quite a bit. That the U.S. is seeing these intense short-term hot events, and so these are all events that are all in line with what we'd expect to see. So we're seeing things like more forest fires in the West. We're seeing hotter fires, but we're also seeing the West, where I grew up, was dependent totally on snowpack. We relied on snowpack in the winter to fill up our reservoirs, and then we had water in the summer, late in the summer. And so this study from Philip Mote at Oregon State, we published this last year. The red circles and the blue circles are what matters. The blue circles mean that snowpack is increasing. The orange circles mean that snowpack is decreasing. So for more than 800 reporting stations across the West over a period of more than 50 years, we've seen a decline in the amount of snowpack. It's warming up. So here, for example, this is Mount Lassen in the northern Sierras and the Cascades. This was snowpack at the end of the season last year. This is one of the reservoirs that depends upon snowpack. The fallow acres in the Central Valley were hundreds of thousands of acres had to be left fallow the last 2 years because they didn't have water. Yet at the same time, we build in the desert environment like there's no tomorrow. Everybody has a swimming pool and it's party on. But then we also need to keep in mind, look back, this is the remnants of the Anasazi civilization. In the late 1200s, they left. They ran out of water. So there is a bit of urgency to this, I would submit. If you look here, I mean, and there's scientists who focus on this issue are trying to figure out where are we going? What are we going to see? This is from a study at Noah Diefenbaugh at Stanford. It was in Geophysical Research Letters. It was looking at the number of extremely hot seasons per decade that we're going to be seeing in the United States. And we're already at 2015, and you're already seeing on the left, you already see when you look at in the Southwest, you're beginning to see orange. But then once you move in decades ahead, we're going to be seeing hot summers more frequently almost every year. And the National Academy of Sciences 5 years ago put this out, but nobody was listening. What happens to impacts of temperature rise per degree centigrade or 1 degrees Fahrenheit? 5 to 10% less total rain across Southwest North America, the Mediterranean, and South Africa. 5 to 10% less river stream flow. This is kind of the stuff that you need to grow food. Right? 5 to 10% lower crop yields across the U.S., African corn, Indian wheat. This was 5 years ago. These are all the kinds of things that we can expect as temperatures keep going up. This study from David Batista and Roz Naylor that was in Science 6 years ago still gives me chills because of what it means. They looked at all of the carbon emission scenarios. We keep burning coal and oil. We keep driving up global carbon emissions, and the question is, what impact over time? It's hard to know, right? It's hard to have a crystal ball, but it's useful to at least do scenarios, to try to figure out where we might be going. And what you see here, 2040 to 2060, summers that are warmer than the warmest on record. And what you see here is like, well, the yellow, that's more than half the time by mid-century here, but what you see is a big band across the 30 degrees north to 30 degrees south area. That's where about 3 billion people live, and they all depend upon subsistence, rain-fed agriculture. And if you heat things up, I already showed you the charts about heat, drought, extreme rainfall, things are going to get unstable there. And then if you go to the end of the century, it's like everybody's going to be hot if we keep disrupting the global carbon cycle, essentially. And we're already seeing it in some regards. This is a piece from David Lobel that was in Science 4 years ago. Corn is already down 3.8 and wheat's down more than 5% globally as a result of this. So I'm going to turn the corner and basically then say, let's talk about sustainability. Let's talk about stewardship. And what does that mean? It means the careful and responsible management of something that's entrusted to one's care, right? It's entrusted to our care. We're driving the car. It's all up to us, individually, collectively, me, all of my peers, and everybody who's coming after. And so maybe we need to think about how can we stand up and confront the future? How can we face what's coming? Because it's an important thing. We can continue to go down this path. We can, and we have now for several hundred years. But data is showing us, science as a part of our society is showing us it's like warning lights, right? And we can do this, well, let's just cover up the ice. Let's just cover up the glaciers, no problem, it'll still be there. But that's a bit like putting a Band-Aid on something but not figuring out what the cause of the bleeding is. Or we'll just take the ice to wherever we need it if we've run out of water, no problem. But those are all kind of short term, and they're kind of like they're Band-Aid. So maybe it's time to rethink our approach and go back to that idea of what kind of sunshine we're having our relationship with. Maybe it's time to think about how can we reanimate the idea of the relationship with current sunshine that has been the building block of the world that we live in until about 300 years ago. And so this is actually something to think about. We've always heard this argument about, oh, it's the environment versus jobs. You can't protect one and save the other. I would submit that perhaps without an environment, you're not going to have an economy. That as Gaylord Nelson, the senator from Wisconsin, said, the economy is a wholly owned subsidiary of the environment and not the other way around. So let's come back to the question of fossil sunshine or current sunshine, right? We know what this path is. It's built the modern world. But what's fascinating about this right now is we depend upon it. We rely upon it. It has made the world that we inhabit, and we live a good life. But the paradox is that it's actually endangering the future of the world that we enjoy. So that's why if we can begin to think about how do we repower the planet, how do we get back to the power of current sunshine to produce essentially a lower carbon energy future. Part of it is that once you get the energy from the sun and the wind, it's like the energy is free, right? Once you build the windmills and the solar farms to capture it, you're not paying for any more energy, unlike fossil energy. So what are some of the options? What are the choices that you might have? All of these: efficiency, conservation, low carbon fuel, renewables, renewed forests, capturing and storing carbon. We're trying to power the planet with low carbon energy, but we're also trying to keep from adding more carbon to the atmosphere because we have a demonstrable evidence showing that more carbon is changing the planet. So maybe it's better fuel economy, right? Next time you buy a car. Maybe it's not even buy a car. Maybe it's do mass transit. Maybe it's rebuild your buildings so they're energy efficient, right? Back when compact fluorescent bulbs were in vogue, before LEDs came along and made quantum leaps even more efficient, this CFL bulb that this guy's holding, if you put one of those bulbs in your house for 1 year, you would avoid burning a 1/4 ton of coal. It makes a difference. Little actions make a difference. Or maybe it becomes rethinking where we're getting our energy. Biofuel from algae. So we're not growing corn put in our cars. It's like you're taking good farmland that you could use for food and turning it into energy. And yes, it is absolutely more solar, electric. The energy is free. It's more wind. It's also saving forests. Remember when I showed you the graphic about how the Siberian forests were soaking up the carbon? You got to keep the forests if you want to try to keep the carbon from adding up. They're like lungs of the planet. They're big sponges. And also now we're also thinking about how can we soak up the carbon that we've already got in the atmosphere, or how can we actually capture the carbon that we're burning when we're creating energy? That's one of the big questions. Can you capture carbon at the smokestack of a power plant? How effectively can you do it? How much at scale? It's a big question. Or maybe it's geothermal. And did you know that in the United States, 19% of the electricity still comes from nuclear? It's more than 80% in France. I mean, it is a 24/7, 365 carbon-free energy source. There are whole other questions about security, safety, and what to do with the waste, but given the question of once you understand what's happening with the atmosphere, part of this is there's a whole suite of choices that maybe you need to keep in mind. You can't just arbitrarily take things off the table. Once you understand what carbon is doing to endanger the future of our life and our children's life. So maybe it's a whole range of choices, solar, wind, all of those things. It's kind of a suite, which really was the focus of our issue this month. We wanted to focus on solutions. We wanted to talk about what can we do. And it's a long-term challenge. Look, it's a multi-generational challenge. We're not going to solve the problem tomorrow, but actually one of the biggest things is trying to at least adjust our mindset about it is possible to do these kinds of things. We're not necessarily locked into the old ways of doing things. We featured Germany. Germany is leading the way globally. More than a quarter of their energy comes from renewables right now. They think it's very important. And when you think about Germany, why they're way up there north. How do they get sunshine? They're doing it. They're making a difference. And so it's like the US produces about 13% from renewables. And most of that's from hydro, yet we have an incredible amount of solar energy in the Southwest. So in Germany, they're building out offshore wind. They have huge solar installations, and I know that there's a price to everything. Well, if you cover the wildlands and solar panels, what's going to happen to the animals? Absolutely. If you're going to put up windmills, what's going to happen to the birds? I know, those are big questions, but at the same time, when you understand what's happening to the planet as a result of our reliance on ancient sunshine, you're going to come to the realization we have to do whatever we can to change the dynamic. And here, this is from Mark Jacobson at Stanford. He's done a scenario. Go to our online site, and you can see he's done a scenario for every state in the U.S. What would it look like for every state to be powered by renewables by mid-century? We've done it before. I mean, we created automobiles, Henry Ford. In World War II, we turned over the whole industrial mechanization to the war effort. I mean, if you put your mind to it and you focus on it, things can be done. So last, I leave you with this. I mean, and I come back sort of to the end, to the beginning. It's this idea that's like, so, you know, over the last 60 years, since we first saw this picture of the Earth hole in the late 1960s from the Apollo moon mission, we've learned a whole lot about the planet. And our visions become sharper. We understand a whole lot now about our relationship to the planet, how it supports us, and what we can do to help keep that relationship going for a long time. And so I think that one of the questions that we have to ask ourselves is what are we going to do with all this knowledge that we have? We have an incredible amount of knowledge and understanding now about our place on this planet and where we're going. And so there is a way. We have a clear way that we could make a difference. Perhaps one of the big questions that we have collectively is their will to try to make these kinds of changes. So there, I'm done, and we can talk and throw slings and arrows, whatever you like. So we have some time for some questions. Who would like to pose a question? Stephen.
Thank you so much for coming. My name is Stephen Richardson. I'm in development studies and geography. I'm a master's student here. You showed a lot about photovoltaics and solar panels.
Yep.
People are starting to go to them. The cost for creating them Manufacturing's going down
Right.
extremely, so it's almost able to be purchased by the masses.
Yep.
Electric companies are now charging people to push solar electricity that they've collected.
Right.
When it's get pushed onto the grid, it actually increases their bills. So that's a pushback against solar panels. How can we fix that so people will actually use them? Because it's affordable to use, it cuts down your electric bill, but it increases it because electric companies and utilities are not making money anymore.
You've identified the crux of the matter right there, right? The new world coming into collision with the old world view. And so I guess one thing you can do is you can elect representatives in the public space who are going to support the integration of renewable technologies into the power system. I mean, it's largely a regulatory system, so who are the people who are allowing those surcharges to happen? We've seen it in California too. It's like solar energy is price competitive. So if the energy companies are truly in the energy business, they would be getting on the bandwagon too, because they would see the handwriting on the wall. But I think that there's a lot of money to be made in maintaining the status quo, right? You're going to make as much money as you can for as long as you can by not making a change, but everything will be fine until it's not. And that's what's going to happen, because the price of these alternatives keeps coming down, and it will be cheaper increasingly to go the route you're talking about. Yes, sir.
My name is Bernhard Debatin. I'm a professor in the journalism school. And I really enjoyed your presentation. I enjoyed the photos. I thought it was really a good combination of things. I do want to say one thing about the nuclear, because you said it's 24 hours carbon-free.
Yeah.
The problem with that is that it is only possible to say this when you look at the actual production. Nuclear actually has a huge carbon footprint because of extraction, production, erection of the facilities, and then even bigger because of the storage problems.
Right.
And I think this is one of the big problems that we have, that people have used the climate change issue and the carbon crisis
Right.
to promote nuclear, which, not even talking about the safety issues, which has in fact a huge carbon footprint, which people tend to forget because we are so used to not look at the whole picture.
Whole life cycle analysis, you're totally right. Same thing would apply to solar and wind.
Not the same.
Well, in the sense that you're still using unless you're powering your whole operation by solar and wind to extract the minerals and build the infrastructure for solar and wind, the same kind of thing can apply. I'm not an advocate for nuclear. What I'm just trying to say is it's important to understand what the range of choices are. And I realize that nuclear is a hot button issue for a lot of people. It's like, God, I wouldn't want to eat conventional food when I can pay twice as much for organic. But the point is that it's like, what I'm just trying to say is when you get to the point where you understand what's happening to the atmosphere of the planet as a result of our unrelenting continued reliance on coal, oil, and gas, that then you have to start deciding. I mean, it's like the world, it's like, which is worse? I'm not advocating, but which is worse? All of the nuclear waste in the world sitting on a storage site the size of a football field, or all of the uncontrolled carbon that's in the atmosphere now that's going to determine the climate for my children, their children, and theirs. And that's, I think, there's no easy answers, but I think that it's important to just say, oh, we're not going to take nuclear as an option, when 19% of our electricity, that's 2014 U.S. Energy Agency info, we're still relying on it. So the question is, how do you create essentially, if we're all planet managers and we were in the position of trying to build a sustainable energy future, how would we do it? Would nuclear have to be part of it? Some people would say no. Others might say yes. Fair?
Yeah, I just wanted to point out that that is a general issue that we have to look at.
It's a huge issue. We know, in the 50s, the Atomic Energy Commission said, go ahead and produce commercial nuclear energy in the United States. We'll take the waste off your hand. You know, 65 years later, they're still going, we don't know what we're going to do with the waste. See? Yes, ma'am.
Can you talk about some of the feedback that you've received from doing some of the exposés on climate change in National Geographic? Has there been a heightened sense of urgency?
Has there been a heightened sense of urgency? I think it depends. I think that there's, when we did that first project, Global Warning, in 2004, we got a lot of resignations from people, but they were probably the same people who hadn't finished deciding to resign after we'd been covering evolution. So there was, look, we actually, as an institution, are going to, we're going to subscribe to the idea that science plays a functional role in society, that the National Academy of Sciences, the American Association for the Academy of Sciences, the Royal Society, they play a functional and useful role. And so what we're trying to do is to try to help explain what those findings are to our population. Look, there's about a quarter of the American population that they're never going to read us, they never will, right? But then there's a whole other majority of the population who are trying to sort through this. And that's really what we're trying to do. And when we did that thing in 2004, yes, we had people resign, but we also had a lot of people sending us checks, okay? Yes, sir?
I'm just curious, does National Geographic, you've got a vast membership,
Right.
but not nearly as big as what you might want. I mean, do you have a program, or do you, for example, to make sure that people in powerful positions, decision makers, the top political and economic decision makers in the country, people like the Koch brothers, et cetera, get, if they don't subscribe, get a copy of?
That's a good question. I mean, we've sent, I think we sent this issue to every member of Congress. We did the same thing in the 2004 issue. I think on one level, though, I think it's important to understand that we're not really speaking to policymakers. We're speaking to the people who elect the policymakers. And if the people want to affect change in society, it's going to have to come from the individuals who are going into the voting booth and it's voting for the people who are going to try to enact the kind of policies that the individuals think are important. So that's, as far as our influence, well, so yes, in 1988, there were 11.8 million subscribers. That was the year the society turned 100. And we currently have in the US about 3.5 million. But globally, we have more than 8 million subscribers because we are much more global magazine now. We publish in 36 or so international editions around the world. So while we may have started out as a national US institution, we've become much more global, and we also have a strong relationship with TV networks. So we are able to more than just do it in the magazine. We're doing it on television. We're doing it digitally. I mean, we're trying to sort of like, it's like, let me ask you, how many of you actually subscribe to a daily newspaper? Okay. See, I think that's so what we need to do is we're trying to actually target our audiences through the platforms that
Surely
they use.
Ship is up, I mean, with online, because most of your content, other than, you have some premium content, but most of your textual content is free to read.
Everything is still free. You have to register. Give us your email address and we'll give us your email address and we'll give you the world. Okay.
Oh yeah, I National Geographic in decades.
Yes, sir.
Kind of building off that, when communicating climate change to people and trying to build engagement, narrative is super important, obviously, and you guys are doing a very good job of that, especially with your pictures. It's a super easy way to communicate across value structures and languages or whatever. Do you guys have any outreach programs to reach underprivileged members of society?
Yeah, that's a good question. We have a big education program that we're in schools, that we have a, I think that one thing that we're going to see more is our CEO, his name is Gary Nell, and before he came to the National Geographic, he headed National Public Radio, NPR, and before that, he was in charge of Sesame Street, okay, children's television workshop, and he's very much an advocate for raising up the profile of our work in schools and in communities. I know that doesn't answer your question, but it's like it helps, right? Yes, sir?
Hi, my name is Spencer Hobson. I'm a senior undergrad here in the Urban Planning and Sustainability program.
Yes, sir?
And my question for you is, in terms of a city's government role in planning the development and functioning of our societies, what would you say is like the most important, I know it's hard to narrow it down probably, but the most important thing an urban planning division can do in terms of trying to approach planning and development from, I guess, as Leopold would say, a land ethic, a more ecological view of our place here?
If I were to try to say one thing, figure out where the floodplains are. Don't go there. Try to build, I mean, it's like tree cover is really important to try to reduce runoff. I think when you start talking about where climate change gets personal other than food prices and supply, I think the extreme weather thing becomes really important. And when you look at the instance that we're seeing of more extreme precipitation events, not tied to storms, we just get these storms, that's where it gets really important to make sure that, important infrastructure is not in low-lying areas. Are you doing things to have ways to slow down runoff, those kinds of things. And then it's risk in the planning area. It's like, don't build where you know it's going to flood. I think that would probably be the one thing. Anybody else?
I've got one, Dennis.
Yes.
There are a number of students here who are interested in the profession of environmental journalism. Could you say something about where you see that going?
Sure. So I'll talk a little bit about environmental journalism. I would say if you're interested in that field, to me, I think it's it's a really fascinating nexus between journalism and what we're facing as citizens. The Society of Environmental Journalists is a really good organization to be aware of. They have student memberships. We have an annual meeting each year, sej.org. But one thing I've come to see is, especially as it relates to, say, for example, photographers, I've tried to help photographers understand that it's like, oh, okay, you can go shoot wars, you can go shoot bang bang, and maybe you'll make a name for yourself. But in large measure, social disruption like that going to do that doesn't really get at the underlying reasons why these issues are unfolding. And I think the one thing about environmental journalism is that it helps you make sense of why the changes are that we're seeing across the planet. The global environmental change. When you start looking at the reliance on fuels, when you start understanding the linkage between rising carbon emissions and extreme weather, when you start seeing the connection between with drought, it helps you understand then, well, gee, if like, what was the Arab Spring caused by? It was caused by food price spikes in Tunisia, right? So there's a link to these issues, and I think in one measure, environmental journalism is a great way for you to understand back to source, back to how are we all connected to all those things that we rely on and take advantage of but don't really think about. That's a real important role. I think for us it was this idea, if we do nothing other than to help explain and make connections for people where otherwise they might not have made that connection, then we've done a service. Okay?
Oh, there's one in the back, yeah.
Do you think through environmental journalism things are actually going to change, or are the projections?
I'm sorry?
Do you think through environmental journalism things are actually going to change, or do you think the projections of carbon emission and temperature rising are actually doing this?
I don't think, if you put the burden on environmental journalists to change the world, well, maybe we could. Not just one person, but everybody working together. A good TV program, if you haven't seen it and you subscribe to the National Geographic channel, it's Bill Nye the Science Guy on November 1 is part of, it was a coordinated effort between our magazine and the TV channel. And Bill Nye the Science Guy, who many of you might have heard of, he did a program on our channel called Global Meltdown, the 5 Stages of Climate Grief, and his psychiatrist was Arnold Schwarzenegger, and he kind of walked him through the, like, oh my God, I can't believe this happened, denial, acceptance, depression, anger, all these things, and it's a great show, and he, basically his conclusion was, all of us working together can, as he said, change the world, so, okay?
Great. Well, won't you join me in thanking Dennis for his
Thank you.
presentation?
Thank you.